Hello, today I'm going to talk about a little bit about structural engineering. I'm an architect, but of course I'm always interested in structural analysis. When I was first year of architecture study at the university, I didn't have clear idea of who actually calculate the building structure. I thought architect does all the jobs, but now it's clear that these architect and structural engineer or civil engineer, they are completely different domain. And after a while studying in architecture school, I was questioning myself, okay, then I'm designing a building, but I don't have much idea how we can calculate the structure. We know physically with a physical model, if there is a column, then if there is a slab, if slab is too not long, a big cantilever, then of course it's sticked on my physical model. But this is not applied to real scale of building. So I was always fascinated how structural engineers calculate the building. It's really science and it's precision, and I just appreciate structural engineers' work. So when I was student, I asked some structural engineers. I was working luckily at structural engineering office when I was architecture student, and there I asked one of the structural engineer, hey, I'm very interested in structure of the building, but how can I start with it? What's the learning path? And I know in school, university, you learn a lot of calculation methods, but what would you suggest for me? And he suggested me basically two book, which called Why Building Stands Up. It's written by Mario and Salvadori. And this book is basically going through all kinds of building, structural building components, how the structure work. And from here, I start to understand the terminology about structure and the calculation. I didn't even know what's the support and how where it's supposed to be. Of course, in English we know support, but the calculation ways. And also I didn't know what kind of load. I know there's a gravity, but I didn't know terminology like, for example, dead load or live load or, temperature load. There are so many details in terms of structural engineering, and it's very straightforward. There's no kind of art. There is art in structure, I believe, because when I look at sometimes structural model, they are even beautiful than architectural model. Because architectural model, you just simply put the facade and you hiding all the beautiful structure behind of it. Maybe some of the architect expose it, but it's completely different feeling when you have architectural building envelope or structural model. And then I've gone through all this book and I realized the same author published another book called Why Buildings Fall Down. It gave me even better understanding how why building collapse. And so with those two books, I start to build up my knowledge about structural engineering, and I more actively research myself. And when I was working at structural office around 2.5 years, I had a chance to run specific software called Caramba 3D. It's a really parametric software based on Grasshopper. And this allows me to understand, the logic of structural engineering, where to join the members and how we can organize the model to be. I prepare also architectural planning drawing sets, but sometimes I have chance to talk with engineers to discuss what do you need and how can I prepare your module. And then I start to run about BIM software like Revit. I realized that there is analytical module, which is different than physical components. But then I start to organize this model and prepare for the engineers. And I have better understanding in terms of model preparation. But of course, I'm not engineer, but I think I understand the logic. And my next path was, I was working at BIM consulting company for 1 year. And there, luckily, I met one representative from SOFiSTiK AG. It's a German structural engineering software, which is quite strong. It allows many platform such as Rhino and Grasshopper or Revit platform, and also AutoCAD base. So you can you can calculate your building model, and sometimes you can see the weak part of your building and you can enhance it. Luckily, I was involved with SOFiSTiK AG team, research about base allows me to test the software, and whatever question I have, they help me to understand, and we build up together some kind of workflow between Rhino, Revit, and Grasshopper. I've done about 2.5 years with one of representative by SOFiSTiK AG. And since then, I think my understanding of structural analysis became better and better. And also, somehow I became a BIM manager, where it's one of the big company in Austria, around 800 staffs. But it's in Central Europe and German-speaking country. Is a very well-known company. And there, I have always chance to work together with a structural engineer. So if I have always chance to work together with a structural engineer. So if I have some question about structural detailing, again, I could go directly to the colleagues and ask. Or if they have some, different solution options for structure, then it was great chance to look at their proposal. Or sometimes when we do concept competition, then it's also nice to talk with structural engineer. And I realized that this structural engineering is not only using software to calculate structure, but also it's really based on a lot of experience by structural engineer. It's not only physical calculation. I realized that also they specify, material for the concrete and concrete lengths, all the specifications, and they estimate cost for building project. And I learned a lot last 2.5 years in this multidisciplinary office. And then I continues to evolve myself, at least, when I propose my building design, it shouldn't be kind of joke. I mean, many architects also doesn't care, but which is not bad, because we should push them, all the engineers, to be innovative as well in a way, and we should find good structural engineer who could make it happen. But it's nice to understand this different world. And in this video, I'm just going to shortly explain the the concept and logic of structural calculation with my sketches. And I'm going to make some tutorial series to explore perhaps Caramba 3D, which is Rhino and Grasshopper background, and also SOFiSTiK software. It's also I'm going to more focus on Rhino and Grasshopper background. Then perhaps I also talk about some Revit, which is my strength. Although I don't like the software that much, but yeah, I don't have much strong knowledge of other software for structural analysis. But I hope this series would be interesting for you, or maybe helpful for those architecture students who in structural analysis. At least, we should try also. Okay. So here I'm going to sketch some of the architectural concept drawing. We have this massing study and there's an environment, and we may design the facade or building mass depends on the environment. And here we have street edge condition and the main entrance design. It looks a little bit organic geometry, and also the other part of the building. And that's typical concept design as an architectural concept design drawing. And once the architectural concept is there, the structural engineer review the design, and they also propose structural concept. In this case, they propose the main concept of the structural concept of the structural elements. For instance, the whole building structure and also the building envelope, what kind of concept they can propose. And then structural engineers go to each building part. For instance, here the structural slab, and the analytical surface can be positioned in different different position of the slab. And here, as you can see, if there is a column attached to the bottom of the slab, the analytical line of the column, it still has to be point out at the edge of slab vertices. So those node points must meet each other. And in case there is a support condition, the structural engineer will define different support conditions. And let's say if there is a beam between the column, which is a downstream beam that supports the slab, then the beam, you can also think of a different position of analytical line. You may also think about eccentricity of the beam, and depends on that you could adjust your structural analytical model. The important thing is the beam, the framing analytical line must align with the edge of the slab, the analytical surface, and each node point must meet each other. So I'm just drawing one more story here, and let's say now we may have a road, and there's a point road, and it goes all down to the earth, or we can also apply line road, and we can also apply the area road. So, and there will be maybe bracing structure that need to be also split between the structure. But if we have the junction between wall and column, there might be the gap between the analytical surface and analytical line of the column. This can be correct, depends on your calculation software. But maybe structural engineers also align them together, and the edge condition of analytical surface would be just aligned to the analytical lines of the column. And the building story is critical. If there is a division between the building level, the wall we propose most likely for the surface, the analytical surface most likely to each building level. And the tricky part is this
jumping slab between the slab, and if there is a gap between, you may model with a wall or you may model with a beam. Depends which one is correct. It's not clear, but this you can always talk with your structural engineer, and they may use structural beam and propose the least condition between the slab, or maybe they ask you to model with a wall. Beam system in between the framing, you may draw the beam system with some intelligence solution, but anyhow, between the members, for the most of structural software calculation, you may have to divide them and split at each joint. It's also very depends on software. For example, SOFiSTiK, you don't need to split each interval, but Caramba 3D, you must split every joint. And the importance here is also the nodes between the member. The endpoint must meet at the same point. If there is a small gap or tolerance, then the calculation software simply doesn't like it. Or here we have slab, which might have openings. If openings are not too big for the mechanical elements or the vertical circulation, most of case structural engineer ignore these openings for their calculation. So of course, as an architect, we always discuss with engineer. But let's say there's an analytical surface in the center of the slab, and initially, because of the opening, we of course the analytical surface also include those opening elements. But depends if it's too much detail, the calculation or the meshing geometry of the calculation software in FEA analysis is become too heavy. So in this case, you can ignore these openings unless they are huge opening for vertical circulation or the MEP system. So another jumping slab example here, if we think about, let's say, foundation, where between two slabs are meet each other. In this case, you generally will have two different level of analytical surface, but most of case structural engineer will suggest to join them together and draw it as a one single plane. In that case, you can simplify the structural calculation. But of course, this is really depends on the engineer's experience and also the software, which can calculate the analytical surface. So, but it's good to know all this situation. And the next would be, let me think, I'm going to talk about the steel connections. When you have steel frames or steel members, between the steel members at the joint condition, you could also release the start or end connection point, whether it's fixed or whether it's pinned or whether it's bending moment. Then depends on this definition of your node point, your calculation software also behave differently. So just keep in mind that there's also this joint condition you may need to think about when you propose for static model. And all these details stage. So if it's an early stage, you may ignore it. But where the projects are developed, then you need to think about this detail. And let's say the structural framing, which is not straight but bended, then some case, I'm not too sure if you can calculate the curved beam directly in in calculation software, or you could also approximate those curves with a certain division. So in that case, I think you may have small deviation between curved beam and the divide curves, but most of software, calculation software is they like if beam is approximated, and where the straight beam meet to the curved beam, then the analytical line of the straight beam must meet at the point where the division and that node points must meet each other. Otherwise, there will be calculation mistake. So this, I summarize these 4 points so that between the segments of the approximate beam need to be always split, and the node points must meet each other. Or if there is a jumping slab with a small elevation, then you might draw entire plane to calculate it. And also the openings where is not too critical, then you may ignore it. But what about if we think about the complex slab profile? Maybe the facade, curtain wall systems supports has a like vertical supporting construction. Then you may have depends on design phase. You may have complex slab profile. But in this case, most of structural engineers would simplify also the slab profile. For example, here on the big difference, you may keep the slab edge, but if there's a small profile edge, maybe you could ignore it. So in the end, your structural analytical surface will be something like this. So it's much simpler. Your structural analytical surface will be something like this. So it's much simpler geometry. So in FEA calculation, the mesh geometries are not too crazy in this case. Alright, what about stair? Stair is also part of structural element. So when you model structural stair, they need to be calculated. And for these stair, all this riser and tread can be ignored from calculation, but the important part is your structural stair's core. So the core is going to be measured between the riser and bottom of the sloped stair. And the slope flight, you simplify the analytical surface to calculate in your structural analysis. So this is very standard case of stair analytical model. So now let's think about curved door. The curved door is if it's single curved, it's not that very critical, but if it's double curved, then it becomes very complicated. But let's talk about the single curved door. I think most of FEA software, they support curved door, one single curved word as analytical surface. But likewise, the beam, it's also nice to approximate curved door as multiple planes. Approximate curved door as multiple planes, vertical planes, so that your mesh geometry can be simpler. All this discussion is important points, and you should always think about this analytical model, and not only for the physical model, but the analytical model when it comes to the structural engineering and calculation. Alright, thank you very much for watching it, and I provide all the details of the book information and description of the software down below. And if you like